The building blocks of geometry are the pieces of the puzzle, the pieces of geometric figures that come together to create 2D and 3D figures. We're going to be looking at what these figures are called, what they represent, what they look like, and how to properly write them down. First is a point. This is an exact location represented by a dot. It has no size at all. You wouldn't say that this point was 3 inches long because it's just that one point. And you'll see a capital letter beside it. To write this down, you would use the word point A. You wouldn't just say A. You would say point A, and it needs to be a capital letter. For a line, this is a straight path. It has no thickness and it extends forever in both directions. It is straight. There are no bends or curves. No thickness. It is one-dimensional. It might be 4 inches long, but it's not going to be 4 by 2 inches. It doesn't matter how thick the drawing of the line is. The arrows on each side show that it extends forever in both directions. This is often confused with a line segment that we're going to talk about next. In real life, you might see a line as something maybe like the horizon line. If you were to look into the sunset, it's going to extend forever in both directions. It can be named by either using 2 points, X and Y, or that's a cursive L right there. Sometimes you'll see where there's a lowercase cursive letter, and that is naming the entire line. So I could express that line as either XY or line YX. The order does not matter because if I'm starting here to here, since it's extending in both directions, that's the same as starting at Y and going to X. When you put the line above it, make sure you put the arrows on the ends of those lines, and that differentiates it between the line XY and the line segment XY. A plane is a flat surface. It has no thickness. It extends forever. Think about your paper. Even though your paper doesn't extend forever, that would be similar to a plane. You can piece planes together to make a three-dimensional figure. Think about a rectangular prism. That would have 6 planes pieced together. So this parallelogram around this parallelogram around those points is not meaning that's a boundary there, but we're just including those points together. To name it, you're going to write the word plane and pick any 3 points in there. I did QRS, and I put them in that order just because that's alphabetical. No special reason. You just need to use 3 points and put those in any order, and that will name the plane. For array, this is a portion of a line. It has one endpoint and it extends forever in one direction. You should be familiar with the word ray from our definition for an angle. You'll see that in coming lessons where the 2 rays are put together to make an angle. The notation for it is you take the points GH and put a ray above it, and notice that it has an endpoint and then an arrow on the other side. And you always want to list the endpoint first, because HG is not a ray. Because H is where it's extending, not the endpoint. It's not extending past G. So it is ray GH. That's why we don't have it listed in 2 different ways. And a line segment. This is also part of a line or ray that extends from one endpoint to another. So this could be a portion of a line or portion of a ray. I could name segment GH, and that would be true because it's stopping at H. It's not extending beyond that. So I can write that as either LM with the line above it or ML, and I can list those endpoints in any order. It doesn't matter because I'm still talking about that portion of the line, no matter if I start with L or if I start with M. Another concept we're going to deal with is figures that are congruent. They are congruent if they have the same shape and the same size. So if we look at this isosceles triangle right here, the tick marks right here indicate that those are congruent line segments. The segment AB is congruent to segment BC. That equal sign with a squiggle on top, what that means is those 2 figures are congruent. It's not the exact same segments that you're talking about, but they have the same shape and they have the same size. They are both 20 meters long. Let's apply this with some practice problems. You have two different figures right here, one that's a kite and one that is two intersecting lines. For practice A, B, and C, I want you to use this top figure. For practice D, E, F, I want you to use, actually for D and E you can use this one. For F, you'll have to use that one up there. And really, you'll start to see which figure it comes from as you're practicing these. So go ahead and pause the video, try to name all those figures, and then we'll compare. Okay, practice A, 3 points. You could have named any letter that's on here. A, B, C, D, E, or you could have even came down here and done Q, R, S, T, or U. The key is that you put the word point in front of it and then you use a capital letter. For lines, you have to use the figure that has the arrows on it. So I guess my directions weren't real good before. My apologies. You'll have to come down here and notice that we have lines because they are arrows down here. They're extending in both directions. It's a difference between in this top figure where it's only segments. QS is a line, and line TR. You could have had those letters reversed. You could have said RT or SQ. For a plane, I just need to select 3 points. I started writing ADC, and I changed that because if I say plane ADC, when I look at those letters ADC, they fall in a line, and I think that can be misleading sometimes. So a best practice would be to choose 3 points that do not fall in a line. For rays, I started all of them with U as the end point and extended it out. UR is a ray, US, UQ. You also could have included UT as a ray. Or in all reality, you could have done TR, which means it's starting here and extending this way, or RT, starting here, extending that way. Lots of different rays you could have had. For line segments, there's a lot of those in here. I chose from T to U, Q to U, and T to R. Even though TR is also a line, when I'm talking about TR, the segment, I'm ending at those points. It's not talking about the space that extends beyond that. If you have some other line segments you would like for me to check, just, catch me tomorrow in class and I would be glad to check to make sure that you named the right line segments. It would take a very long time to list all the possible line segments. For congruent line segments, I kind of ran out of room, so I drew a line up here. With the tick marks, AE is congruent to EC because they both have 3 tick marks. AD is congruent to DC. They both have 2 tick marks. Now notice I didn't say that AE was congruent to AD. This one has 3 tick marks, this one has 2 tick marks. So AE and AD are not congruent. We have 3 different pairs of congruent lines. And then AB is congruent to BC.